let's journey through the medieval Europe, a period often overshadowed by the brilliance of the Renaissance that followed. However, it's essential to recognize that the medieval period was not a dark age for astronomy. Instead, it was a time of significant advancements and contributions by European astronomers who laid the groundwork for future discoveries. Our focus today is on the development of Astrolabes and the remarkable work of scholars like John of Sacrobosco. The medieval period, spanning roughly from the 5th to the late 15th century, was a time of great intellectual exchange and growth. With the fall of the Roman Empire, Europe became a melting pot of knowledge, drawing from the rich legacies of ancient Greece and Rome, as well as the groundbreaking works of Islamic scholars during the Islamic Golden Age. This period saw the establishment of monastic schools and universities, which played a crucial role in preserving and advancing astronomical knowledge. Astrolabes, intricate instruments used for solving problems related to the time and the position of the stars, became a symbol of medieval astronomical ingenuity. These devices were not only practical tools for navigation and timekeeping, but also masterpieces of craftsmanship and scientific understanding. The development and refinement of astrolabes in Europe showcased the dedication and skill of medieval astronomers, who continually improved upon the designs they inherited from earlier civilizations. One of the most influential figures of this period was John of Sacrobosco, a scholar whose work left an indelible mark on the field of astronomy. Born around 1195, Sacrobosco was a mathematician and astronomer who authored several key texts, including the Sphaera Mundi. This work became a cornerstone of medieval astronomical education, offering a clear and concise explanation of the Ptolemaic system and the movements of celestial bodies. The importance of the medieval period in the history of astronomy cannot be overstated. It was a time of preservation, adaptation, and innovation, where the knowledge of the ancients was not merely kept alive, but actively enhanced. The work of European astronomers during this time, including the development of astrolabes and contributions of John Sacrobosco, set the stage for astronomical revolution that would come with the Renaissance. This episode will delve into the fascinating developments, highlighting the enduring legacy of medieval European astronomy. The medieval period in Europe, stretching from the 5th to the late 15th century, is often mistakenly characterized as a dark age for intellectual pursuits. However, this era was a crucible of cultural and scientific exchange, profoundly shaping the development of astronomy. The astronomical knowledge that flourished during this period was profoundly influenced by the legacies of ancient civilizations and the remarkable contributions of scholars from the Islamic Golden Age. When the Western Roman Empire fell in the 5th century, Europe experienced significant downfall. However, pockets of learning persisted, and the preservation of knowledge became a vital endeavor. Monastic schools and later universities emerged as key institutions in this mission. Monasteries in particular played a crucial role in maintaining and copying ancient texts, including astronomical works from Greek and Roman sources. This period also saw the translation movement, which brought a wealth of knowledge from the Islamic world to Europe. The Islamic Golden Age, spanning from the 8th to the 14th centuries, was a period of unparalleled intellectual achievements in the Islamic world. Scholars like Al-Khwarizmi and Al-Battani made groundbreaking contributions to astronomy, mathematics, and optics. Their works were meticulously recorded in Arabic and later translated into Latin, becoming essential texts for European scholars. The transfer of this knowledge was facilitated by the Crusades, trade, and the Reconquista, which opened channels of communication between the Islamic world and Europe. Translations of key astronomical texts such as Ptolemy's Almagest and Al-Battani's De Scientia Stellarum were pivotal in shaping medieval European astronomy. These works provided a comprehensive understanding of the Ptolemaic system, which described the geocentric model of the universe. European scholars eagerly embraced these translations, incorporating them into their studies and teaching. Monastic schools and universities became the epicenters of intellectual revival. Monasteries, with their scriptoriums, were instrumental in preserving and disseminating astronomical knowledge. They copied manuscripts, ensuring the survival of ancient and Islamic works. Universities, which began to flourish in the 12th century, became hubs of learning and scholarship. The University of Paris in particular emerged as a prominent center for astronomical studies. The establishment of universities marked a significant shift in the dissemination of knowledge. These institutions fostered a scholarly community that valued inquiry and debate. Astronomy was integrated into quadrivium, the advanced curriculum of the medieval university, alongside arithmetic, geometry, and music. This formal education system allowed for a systematic study of celestial phenomena and the refinement of astronomical theories. The historical context of medieval Europe thus set the stage for significant advancements in astronomy. The synthesis of ancient, Islamic, and contemporary knowledge created a fertile ground for innovation. European astronomers, building on this rich legacy, made substantial contributions that would eventually pave the way for scientific revolution of the Renaissance. The astrolabe is one of the most fascinating and versatile instruments in the history of astronomy. It is an ancient tool used to solve problems related to time and the position of celestial bodies, and its development and refinement during the medieval period in Europe significantly contributed to advancements in astronomical knowledge and practice. An astrolabe can be described as a two-dimensional model of the celestial sphere. It consists of several key components: the matter, the main body, the tympan, a plate engraved with coordinate lines for a specific latitude, the rete, a rotating star map, and the alidade, a ruler used for sighting objects. By aligning the rete with the positions of stars, astronomers could simulate the apparent motion of celestial objects and make various astronomical calculations. The significance of astrolabe in medieval astronomy cannot be overstated. It served as both an educational tool and a practical instrument for astronomers. Medieval scholars used astrolabes to teach and learn about the movements of stars, the sun, and the planets. This hands-on approach allowed them to visualize complex astronomical concepts and gain a deeper understanding of the cosmos. The development of astrolabes in Europe was influenced by earlier design from ancient Greece and the Islamic world. The earliest known astrolabes date back to the Hellenistic period, around the 2nd century BCE, with contributions from Greek astronomers like Hipparchus and Ptolemy. However, it was during the Islamic Golden Age that astrolabes were significantly refined and improved. Islamic scholars such as Al-Fazari and Al-Zarqali made crucial advancements in the design and use of astrolabes, and their knowledge eventually reached Europe through translations of Arabic texts. In medieval Europe, the process of developing and refining astrolabes involved several stages. Initially, European scholars translated and studied Arabic manuscripts on astrolabes, gaining insights into their construction and application. One of the key figures in this process was Gerard of Cremona, a prolific translator who brought numerous Arabic scientific works to the Latin-speaking world. Once European scholars understood the principles behind astrolabe construction, they began creating their own versions. These medieval European astrolabes often featured intricate designs and high levels of craftsmanship. Metalworking techniques improved, allowing for more durable and precise instruments. The refinement of engraving methods enabled astronomers to create more accurate and detailed star maps on the rete. The practical uses of astrolabes in medieval Europe were diverse and essential. One of the primary applications was in navigation. Mariners used astrolabes to determine their latitude by measuring the altitude of the sun or a star above the horizon. This information was crucial for long sea voyages, enabling sailors to navigate with greater accuracy and confidence. Astrolabes also played a vital role in timekeeping. By observing the positions of celestial objects, astronomers could calculate the time of day and night. This was particularly important for religious purposes such as determining the times for daily prayers in Islam and setting the date for Easter in Christianity. Monasteries and cathedrals often had resident astronomers who used astrolabes to maintain accurate liturgical calendars. Additionally, astrolabes were used for various astronomical observations and calculations. They could determine the altitude and azimuth of celestial objects, predict the rising and setting times of stars, and even solve complex problems related to spherical trigonometry. This versatility made them indispensable tools for medieval astronomers and scholars. The development of astrolabes in medieval Europe was a pivotal moment in the history of astronomy. These instruments, with their roots in ancient Greece and the Islamic world, were refined and adapted by European scholars to meet their specific needs. The practical applications of astrolabes in navigation, timekeeping, and astronomical observation highlight the significance in medieval society. John of Sacrobosco, also known as Johannes de Sacrobosco or John of Hollywood, was a pivotal figure in medieval European astronomy. His contributions to the field during the 13th century left an enduring legacy that continued to influence astronomical thought for centuries. Born around 1195, likely in Hollywood, England, Sacrobosco pursued a career as a mathematician, astronomer, and educator, eventually becoming a master at the University of Paris, one of the leading intellectual centers of the medieval world. One of Sacrobosco's most significant contributions to astronomy was his seminal work, the Sphaera Mundi. Written around 1230, this concise yet comprehensive treatise on the Ptolemaic cosmological model became a cornerstone of medieval astronomical education. The Sphaera Mundi provided a clear and accessible explanation of the geocentric model, which stated that the Earth was at the center of the universe with the Sun, Moon, planets, and stars orbiting around it in perfect spheres. Sacrobosco's De Sphaera Mundi was remarkable for its clarity and didactic approach. It was divided into 4 parts, each addressing a specific aspect of Ptolemaic system. The first part described the shape and dimensions of the Earth, affirming its sphericity. The second part focused on the celestial spheres and the motion of the heavenly bodies. The third part explained the phenomena of solar and lunar eclipses, while the fourth part discussed the rising and setting of stars and planets. This structured presentation made complex astronomical concepts more accessible to students and scholars, contributing to the widespread adoption of the Ptolemaic model in medieval Europe. The impact of De Sphaera Mundi on medieval astronomy was profound. It became the standard textbook for teaching astronomy in European universities for several centuries. Its influence extended beyond the classroom, as it was translated into multiple languages and widely disseminated. Sacrobosco's work laid the foundation for subsequent astronomical research and education, bridging the gap between the ancient Greek and Roman astronomical knowledge and the emerging scientific developments of the Renaissance. In addition to the Sphaera Mundi, John of Sacrobosco made several other notable contributions to mathematics and astronomy. He wrote Algoritmus, a treatise on arithmetic that introduced the Hindu-Arabic numeral systems to European students. This work helped popularize the use of Arabic numerals and the concept of zero, which were essential for advancements in mathematics and science. Sacrobosco also authored a commentary on the Computers, a medieval text used for calculating the date of Easter. In this work, he demonstrated his expertise in calendar calculations and his deep understanding of the relationship between astronomical phenomena and timekeeping. This knowledge was crucial for the accurate determination of liturgical dates and the synchronization of religious observances with celestial events. As a teacher at the University of Paris, Sacrobosco's influence extended far beyond his written works. He played a crucial role in shaping the curriculum and training future generations of astronomers and mathematicians. His pedagogical approach emphasized clarity, logical reasoning, and the importance of observational evidence, principles that would later underpin the scientific revolution. Sacrobosco's contribution to astronomy and mathematics were instrumental in preserving and advancing scientific knowledge during the medieval period. His works served as a bridge between the ancient and medieval worlds, ensuring the continuity of astronomical learning. His emphasis on clear and systematic explanations set a standard for scientific writing that continued to inspire scholars long after his time. John of Sacrobosco's contributions to medieval astronomy were monumental. His major work, De Sphaera Mundi, provided a clear and accessible explanation of the Ptolemaic system, becoming a cornerstone of astronomical education in medieval Europe. His other contributions to mathematics and calendar calculations further solidified his legacy as a key figure in the history of science. Through his writings and teachings, Sacrobosco influenced generations of scholars and laid the groundwork for astronomical advancements that would follow in the Renaissance and beyond. In addition to John of Sacrobosco, several other European scholars made significant contributions to astronomy during the medieval period. Among these notable figures were Gerard of Cremona and Albertus Magnus, whose work complemented and built upon each other's discoveries, creating a rich tapestry of astronomical knowledge that laid the groundwork for future advancements. Gerard of Cremona was a pivotal figure in the transmission of astronomical knowledge from the Islamic world to medieval Europe. Born in Cremona in Italy around 1114, Gerard was driven by a passion for learning and an eagerness to access the vast body of knowledge preserved by Islamic scholars. To this end, he traveled to Toledo in Spain, which was then a thriving center of intellectual exchange between Christian and Muslim scholars. In Toledo, Gerard immersed himself in the study of Arabic and dedicated himself to translating scientific texts from Arabic into Latin. One of Gerard's most significant achievements was his translation of Ptolemy's Almagest, a comprehensive treatise on the geocentric model of the universe. This work, originally written in Greek, had been preserved and expanded upon by Islamic astronomers. Gerard's translation made the Almagest accessible to European scholars, providing them with a detailed and systematic account of the motions of celestial bodies. His translation was instrumental in disseminating the Ptolemaic model throughout medieval Europe and became a cornerstone of astronomical education. In addition to the Almagest, Gerard translated numerous other astronomical and mathematical works, including texts by Al-Khwarizmi and Al-Battani. These translations enriched the European intellectual landscape and provided the foundation for further developments in astronomy. Gerard's meticulous work bridged the gap between the Islamic Golden Age and the scientific revival in the medieval Europe. Albertus Magnus, also known as Saint Albert the Great, was another towering figure in medieval European scholarship. Born around 1200 in Swabia, Germany, Albertus was a Dominican friar, philosopher, theologian, and scientist. He was known for his encyclopedic scientific knowledge and his efforts to reconcile Aristotelian philosophy with Christian theology. Albertus's contributions to astronomy were part of his broader quest to integrate empirical observation with philosophical inquiry. Albertus Magnus made significant strides in the study of natural sciences, including astronomy. He was a proponent of the observational method and emphasized the importance of direct observation of celestial phenomena. His works included detailed descriptions of the movements of celestial bodies, the phases of the moon, and the nature of eclipses. Albertus was also one of the first medieval scholars to challenge certain aspects of the Ptolemaic system, advocating for a more nuanced understanding of celestial mechanics. Albertus's influence extended beyond his writings. As a teacher at the University of Paris and later at the University of Cologne, he mentored a generation of scholars, including the renowned philosopher and theologian Thomas Aquinas. Albertus's emphasis on empirical observation and his integration of scientific and philosophical inquiry helped shape the intellectual climate of medieval Europe, paving the way for scientific advancement of the Renaissance. The contributions of Gerard of Cremona and Albertus Magnus were complementary and mutually reinforcing. Gerard's translation provided European scholars with access to a wealth of astronomical knowledge from the Islamic world, including the Ptolemaic system and the works of pioneering Islamic astronomers. This influx of knowledge created a fertile ground for intellectual growth and innovation. Albertus Magnus, building on this foundation, emphasized the importance of empirical observation and sought to integrate the newly acquired astronomical knowledge with philosophical and theological principles. His efforts to challenge and refine existing astronomical models contributed to a more sophisticated understanding of celestial mechanics. Together, Gerard of Cremona and Albertus Magnus exemplified the collaborative nature of medieval scholarship. Their work, along with the other notable scholars, created a rich and interconnected web of knowledge that spanned cultures and centuries. This intellectual legacy not only preserved the astronomical achievements of ancient and Islamic scholars, but also fostered the conditions for the scientific revolution that would transform our understanding of the cosmos. The contributions of Gerard of Cremona and Albertus Magnus to medieval astronomy were profound and far-reaching. Gerard's translation of key astronomical texts from the Islamic world enriched the European intellectual landscape, while Albertus's emphasis on empirical observation and philosophical inquiry advanced the study of celestial phenomena. Together, their work complemented and built upon each other's discoveries, laying the groundwork for astronomical advancements that would follow in the Renaissance and beyond. Their legacy serves as a testament to the power of intellectual collaboration and the enduring quest for knowledge. Medieval astronomers faced a multitude of challenges and controversies as they sought to advance their understanding of the cosmos. These obstacles ranged from limited resources and access to texts to opposition from religious authorities and societal constraints. Despite these hurdles, medieval scholars persevered, contributing significantly to the field of astronomy and laying the groundwork for future scientific advancements. One of the primary challenges faced by medieval astronomers was the scarcity of resources and access to knowledge. The fall of the Western Roman Empire in the 5th century led to a period of political and social instability in Europe. Many ancient texts, including astronomical works, were lost or scattered. Monastic schools and later universities played a crucial role in preserving and copying these texts, but the process was slow and labor-intensive. The availability of astronomical instruments such as astrolabes and armillary spheres was also limited, making it difficult for scholars to conduct precise observations and measurements. In addition to these resource constraints, medieval astronomers often faced opposition from religious authorities. The dominant religious institutions of the time, including the Catholic Church, held significant influence over intellectual pursuits. While the Church was not inherently opposed to the study of astronomy, certain aspects of astronomical inquiry were viewed with suspicion. Scholars who proposed ideas that seemed to contradict religious doctrine risked being censored or punished. This tension was evident in the debates over the geocentric versus heliocentric models of the universe. One of the most notable controversies in medieval astronomy was the conflict between the Ptolemaic geocentric model and early heliocentric ideas. The Ptolemaic system, which placed the Earth at the center of the universe with celestial bodies orbiting in perfect circles, was widely accepted by both scholars and religious authorities. However, some astronomers began to question this model, proposing alternative explanations for the observed motions of celestial bodies. For example, the 14th century scholar Nicholas Oresme suggested that the apparent daily motion of the stars could be explained by the Earth's rotation rather than the movement of the entire celestial sphere. Although Oresme ultimately upheld the geocentric model, his ideas hinted at the possibility of a heliocentric system. Controversies also arose from differing interpretations of astronomical phenomena. For instance, the occurrence of comets and eclipses often sparked heated debates among medieval scholars. Some viewed these events as omens or divine messages, while others sought to understand them through natural explanations. Albertus Magnus, for example, challenged the prevailing belief that comets were atmospheric phenomena, arguing instead that they were celestial objects with predictable paths. His ideas were controversial at the time, but laid the groundwork for a more scientific understanding of comets. Despite these challenges and controversies, medieval astronomers made remarkable strides in their field. They developed sophisticated instruments, improved observational techniques, and refined existing models of the universe. Their work was often characterized by a spirit of inquiry and willingness to question established ideas even in the face of opposition. The resolution of many controversies in medieval astronomy came through a combination of dialogue, debate, and empirical evidence. Scholars engaged in rigorous discussions, often within the framework of the emerging university system, to test and refine their ideas. Observational evidence played a crucial role in resolving debates, as astronomers sought to reconcile their theories with the motions of celestial objects. The challenges and controversies faced by medieval astronomers were numerous and complex. Limited resources, opposition from religious authorities, and the fragmented nature of knowledge dissemination all posed significant obstacles. However, through perseverance, collaboration, and a commitment to empirical observation, medieval scholars made lasting contributions to the field of astronomy. Their work laid the foundation for the scientific revolution of the Renaissance, demonstrating the enduring power of intellectual curiosity and resilience in the face of adversity. One of the enduring legacies of medieval astronomy is the preservation and transmission of ancient and Islamic knowledge. The efforts of translators and scholars such as Gerard of Cremona and John of Sacrobosco ensured that crucial astronomical texts and concepts were passed down to the future generations. This preservation of knowledge allowed later astronomers, including Copernicus, Galileo, and Kepler, to build upon the work of their predecessors and make groundbreaking discoveries that revolutionized our understanding of the cosmos. The development of astronomical instruments during the medieval period also had a lasting impact. The Astrolabe, for example, evolved into more sophisticated tools used in modern astronomy. The principles behind the Astrolabe's design and its applications in navigation and timekeeping laid the foundation for the development of sextants, telescopes, and other advanced instruments. Today's astronomers continue to rely on precise observational tools to study celestial phenomena, reflecting the enduring influence of medieval innovations. Modern advancements in astronomy often draw inspiration from the meticulous observational methods and empirical approach championed by the medieval scholars. The emphasis on empirical evidence, pioneered by figures like Albertus Magnus, remains a cornerstone of scientific inquiry. This methodical approach has led to numerous discoveries, including the identification of exoplanets, the detailed mapping of our galaxy, and the exploration of distant celestial objects using advanced telescopes and space missions. Ongoing research in the history of science also highlights the contribution of medieval astronomers. Scholars continue to uncover and analyze historical texts, shedding light on the intellectual achievements of medieval Europe. This research not only deepens our understanding of the past, but also informs contemporary discussions about the development of scientific thought and the interconnectedness of different cultures and civilizations. Additionally, the legacy of medieval European astronomy is celebrated through various educational initiatives and public outreach programs. Museums, universities, and cultural institutions often showcase the achievements of medieval astronomers, emphasizing their role in shaping the trajectory of scientific progress. By highlighting the historical contexts and contributions of medieval scholars, these initiatives inspire new generations to appreciate the rich heritage of astronomy and pursue their own scientific endeavors. The legacy of medieval European astronomy remains relevant and influential in the modern scientific world. The preservation of knowledge, development of instruments, and empirical approach of medieval scholars continue to inspire and inform contemporary astronomical research. As we explore the cosmos and make new discoveries, we stand on the shoulders of the medieval giants who paved the way for our understanding of the universe. In this episode, we've journeyed through the medieval Europe to uncover the significant contributions of astronomers during this period, highlighting the development of Astrolabes and the impactful work of scholars like John of Sacrobosco. We've explored the historical context in which these advancements took place, noting the influence of early astronomical knowledge from ancient civilizations and the Islamic Golden Age, as well as the pivotal role of translations and establishment of monastic schools and universities. We delved into the development of Astrolabes, explaining their construction, significance, and practical applications in navigation and timekeeping. This fascinating instrument showcased the ingenuity of medieval astronomers and their ability to refine and enhance the designs they inherited from earlier civilizations. The contributions of John of Sacrobosco, particularly his seminal work the Sphaera Mundi, were examined in detail. His clear and systematic explanations of the Ptolemaic system became a cornerstone of medieval astronomical education and influenced generations of scholars. We also highlighted other notable figures like Gerard of Cremona and Albertus Magnus, whose work complemented and built upon each other's discoveries, creating a rich and interconnected web of knowledge. We addressed the challenges and controversies faced by medieval astronomers, including limited resources and opposition from religious authorities. Their perseverance and commitment to empirical observation laid the groundwork for future scientific advancements. Reflecting on modern developments, we noted how the legacy of medieval European astronomy continues to inspire contemporary research and discoveries. The preservation of knowledge, development of instruments, and empirical approach championed by medieval scholars remain foundational to modern astronomy. The importance of medieval European astronomy in the broader history of the field cannot be overstated. The work of these scholars, despite the challenges they faced, laid the foundation for the scientific revolution of the Renaissance and continues to inform and inspire our understanding of the cosmos today. Their legacy serves as a testament to the enduring power of intellectual curiosity and the relentless pursuit of knowledge. Thank you for watching. Keep looking up.